There we go. Okay, so I'm going to go ahead and start with a simple idea, which is that, as you know, with systems, you did this already, there are multiple methods of solving. There's multiple methods, and depending on the problem, you use different methods of solving the question. So we're going to go ahead and understand why we use multiple methods. And the reason why is because people in general are incredibly lazy. People don't like doing work, and mathematicians are especially lazy. The entire idea behind math as a history of the last 2,000 years is to make our lives easier and faster. I understand that most of you don't like it and don't want to deal with it but the reason why we do this is because we are lazy. And that's the reason why when you see a specific type of equation, you want to know the different methods so you can do which one is easiest and fastest. Unless, of course, the question asks you to answer it in a specific method, but that's not the point. Now, when I say lazy, we change the word to sound good to efficient. They are the same thing. Just get that out of the way. So the question that I'm going to ask you guys first is, what methods do you remember about doing this? Anyone who wants to, you can raise your hand or you can just yell it out. What methods do you remember? Go ahead. Substitution. All right. Substitution is nice. Substitution is easy. And I'm going to give you an example, and you guys can work from that, okay? Now, do you remember when substitution is a good idea to use? Go ahead. Variable on one side of the equation. That is one good reason to do it. Another good reason for substitution is when you have one of the variables with no coefficient. Think about it that way, because it's really easy to get that one variable on one side and just substitute it that way. So I'm going to give you an example using that. Now, the examples I'm giving you are incredibly simple. They are not going to be as easy as you'll ever have it on an exam. This is just to make sure that you understand the concept and the review, because doing it harder and doing it easier are the same. It's just more algebra. So the example that I'm going to give you is, and by the way, yes, I'm left-handed and have horrible handwriting, so please, please, please be gentle. Horrible, horrible handwriting, as I said. So, and of course, I also should have memorized this by now, but I have not, and that is because nervous. Remember, nervous. And don't worry, I will get better as with the numbers as we go through it further.
Is that a 3 or a 2?
3, 2, nothing, 3.
Good. And a 7?
7, negative 12.
Word.
Any other questions about what the numbers are? No. No more questions about what the numbers are. Awesome. Okay, so based on this idea, what are we going to start with? We basically just went over the idea that we're going to be using substitution here. And why are we going to be substituting? Because there is no coefficient. That is a 1. There is a 1 there. So we're going to start by doing what?
Solve for x.
Yes, and how are we going to solve for x?
Add 3y to both.
Add 3y to both sides. And when we add 3y to both sides, we get what?
X equals.
Yes, which is we're going to just write as 3y plus 7. Now, when you do that, what do you do here? We're calling it now substitution, so we're going to go ahead and substitute. So plugging 3y plus 7 in for 3x here, what do you get? Which is what? 9y plus 21. So when you have 9y plus 21, how do we finish this?
You equal it to negative 12.
Plus 2y.
You still, yes, you have to add the plus 2y because it's still there. And you would have it equal to negative 12.
Y plus 3. Yeah.
And y equals what?
3.
Does it?
Yeah.
So you have 11y equaling negative 33.
Oh, yeah. Negative 30.
-3. Okay, now you have y equals -3. What do you do?
Nothing.
Plug in the Y.
You still need to find x. That's correct. You plug it in. So, with the idea that y equals -3, which of the two starting equations do you want to plug it into? Sure. Okay, so doing that, 3y, you've got -3y, and you've got y equals -3. What does that give you? It gives you x minus a -9 equals 7.
Oh. 16.
Wait, you lost.
No, wait. It is.
And it looks like there may have been something that was going on wrong here.
You did.
Y equals negative, okay. We got y equals -3, right? So it's -3 times -3 equals x plus 9 equals 7. So x plus 9 equals 7, which means that x equals -2. Great. So if you had, as an example, a more complicated problem using something where you had either one coefficient or with one on one side, you understand how the basics work with this, and again, using simple numbers. In general, having 3 and -2 probably not going to be on the test. Okay, so with that as a basis, what do we have as a second method? Elimination. Why would we use elimination?
Because we have a
It's easy is one, actually, it's easy is a really good answer. If you find a specific method easier, even if it's not necessarily appropriate for the problem, it's still going to work. So having the answer be it's easy is fine. However, there are specific circumstances where where elimination is easier than other methods. And generally, you're going to have that happen when you have one coefficient for one of the variables be a multiple of a coefficient for another variable, therefore making it so that you eliminate really, really simple. So we're going to go ahead, and once again, I'm going to have a terrible looking example for that, which is once again slightly too easy for anything you're going to see on an exam. But this is just an example, and it's how you would start to get into things that are distinctly more complicated. I am still going to write it terribly because my handwriting is awful. And this marker is also now decided to die. And the purple decided to work much nicer, and we're going to go ahead and go with that, yeah. It's not that bad, it's still bad, it's just not as bad. You see that one, right? See what all the numbers are? And it would probably help if I also use the correct equations that I wrote. Right. It would probably help if I actually use the ones that I meant to use for this example. Guys. All right, that is the example that I'm using for this. So, where would we start? Go ahead.
By 2.
Either one works. It's just dependent on how you want to do it. So, we're going to multiply this one by 2. So we're going to go ahead and multiply everything here by 2. When we do that, we're going to end up with 6x minus 4y equals 18. Now we'll go ahead and rewrite the other one so that we can just do it real easy. It's 10. So now we add these together, and what do we get? Sorry, this is 9 times 2 is 18 plus 10 is 28. Yes? Therefore, x equals, there we go. Again, like I said, very easy examples. We're working with small numbers here. So if x equals 2, what are we going to do at this point?
Plug in X for
We're plugging in x. Which one do you want to plug it into?
the first one.
Sure. So you plug x equals 2 in the first one. You have 3 times 2 equals. Really?
6.
Okay, 6. So we have 6 minus 2y equals 9. How do we solve that?
You subtract 6, you get
Okay, you get 3. So negative 2y equals 3.
3y.
Hmm?
Negative 3.
Negative 3 over 2, not
3 over 2.
If you do this, remember, you're going to have 6 minus 2y equals 9, which will get you to negative 2y equals 3, which gets you to negative y equals 3 halves, y equals negative 3 over 2. And that is getting smaller and uglier as we go. So that is the first two methods. Now, what is next? Let's graph it. Graphing. Now, graphing is obviously going to be somewhat annoying in certain circumstances, but remember, I made this easy. So at least the answer is going to be very easy. So, obviously you can graph this on any paper you want. You don't really need graph paper for this because we don't need to get that specific because let's just say most of these things are going to be either halves or whole numbers, okay? So the graphing exercise or the graphing example is going to be, and let's just stick with purple because why is it not, right? And I'm just making sure that I stick with the numbers I used here because it's important for me. And all right, so how are we going to start this graphically?
Um,
All right, go ahead and say it again. Solving for y. That is the easiest way to do it. Let's get it into y equals mx plus b form and make it so that finding the slope is easier. All that kind of fun stuff. Really, really simple. So which equation do you want to start with? And of course, it would probably help if I put the y there. Yes. There is a y. Really, there is. All right, so why don't we go ahead and start with the top equation because things. So you want to obviously start with the 2y being on one side, and then you'll get rid of the 2. So if you do that, what are you doing first? Subtracting 3x. After you subtract the 3x, what are you doing?
divided by 2.
Dividing by 2, which gets us to the equation of y equals. Go ahead, anyone.
Negative 3 over 2x plus.
Negative 3 over 2x plus 9 over 2. Absolutely correct. Okay. Second equation.
Subtract 4x.
You got a negative on the y. Do you want to do it that way?
Divide the whole thing by 4.
Or you can go ahead and. Either way, you end up. How do you guys want to do it?
I say subtract 4.
Okay, so you subtract 4x. So you have negative 3y equals 12 minus 4x. Yeah?
Just divide negative.
And divide by negative 3? Are we okay with the idea of dividing by negative 3? Do we have a problem with the first step?
Yes.
Yes, we have a problem with the first step. What's the problem with the first step?
You're trying to get y.
The idea is to get y by itself with no coefficient. So we divide by negative 3, and what do we end up getting here?
Y equals negative 4 over 4.
Yeah, but to keep it in mx plus b form, what are we going to do?
Minus.
Is this positive or negative 4 over 3?
Switch it.
Positive 4 over 3. That's correct. And is this going to be a positive or negative 4? Negative 4. Okay. Now, these equations do not look like they're going to have an incredibly easy answer. However, if we wanted to graph these, we'll talk about it instead of actually graphing it, because I promise you right now a graph is going to look even worse. So let's just go ahead and talk about it first, and we'll see what happens from there. So, how would we start this? Where would we find our first point for graphing? After making a graph, where would we find our first point? Y-intercept. What's the y-intercept for the first equation?
0.
Yes, 0, 9/2, which is going to be there. Now, because you've got 0, so the idea is you're setting x equals 0. You're setting x equals 0 and y equals 9/2. Right? So, what number can we work with here to make life easy?
What? To make life?
Yeah, what kind of number can we plug in for x to make it so we have a second point and make life easy? 2. 2 is really easy when you've got 2's in the denominator, right? However, so we're going to go ahead and do that, but there's actually an easier answer because of what I ended up doing with this. What happens when you plug in 3?
Oh, 9 doesn't.
So if you plug in if you plug in 3 for x here, what do you get on with x equaling here? Negative 9/2. What's negative 9/2 plus 9/2?
It's 0.
0, which means that we have a second point available as 3, 0.
Wait. Aren't we just like supposed to?
Yeah, the thing is, if you graph it, you'll find that this is incredibly simple as well, but I'm just going to say it instead, because again, my graph will look terrible. If you want me to make the graph look terrible, I promise you I will do it. You want me to?
No, it's your choice.
It's up to you guys. You want a terrible looking graph?
No.
Thank you for not making me make a terrible looking graph. All right, so we have two. Oh, how many people said yes? Because we had a pretty even. Okay. All right. Why don't we go ahead and have this be why don't we have a vote for it? Anyone who says yes, go ahead and raise your hand. Yes for a terrible graph. All right. Thank you guys. You guys are awesome. All right. So that's what, about 9? How about for no terrible graph?
No. We won. We won.
Awesome. So terrible graph it is. All right. So we're gonna go ahead and start like that. Hey, if you wanted a terrible graph, you get a terrible graph. So you know perfectly well that you got a 9/2 up here. So 9/2 is going to be right around here. You also know you have, what is your other point that we just worked on? 3, 0. So we now have a line that basically will go between those. I will draw the line in a minute. Let's go ahead and do the other equation. Okay? So based on doing the exact same thing for the other equation, where are we going to start?
-4.
0, -4.
0, -4. And it is not even close to scale. So, sure, it doesn't matter. So we've got 0, -4. Now, what kind of point will we make it really, really, really easy to work with this equation? When you have a 4/3 in the denominator. 2? 2's, when you have a 4/3 on the denominator, working with a 3 sounds like it's going to be really, really easy. So what's going to happen when you put a 3 in for x? All right, 4/3 times 3 equals what?
That's a 4. I thought that's a 6.
Okay, if you have 4/3 and you multiply it by a 3, what are you going to get? 4. So, and therefore, if you have y equals 4 minus 4, what's y?
0.
Therefore, what is the point that we have to work with?
0.
Amazingly enough, that is 3, 0. So we have 2 lines, one of which is a curvy line that does that. The other is a curvy line that does that. So, what is the answer to this particular system? Curvy line, yes. What is the answer to this particular system? Yeah, the point of intersection, which is
3.
3, 0. Yes, 3, 0. Now, how many answers, when you have a system of equation with two linear equations, how many answers can you get? How many answers can you have if you have a linear if you've got two linear equations?
2.
How many different types of answers can you have? 3. What are the 3 different types of answers? No, those are the 3 methods that we're using. There are 3 types of answers you can get when you have any sort of, you have 2 equations, you have a system.
Slope.
We're working with that. That is correct, and you were what we were going to say exactly. The same thing, except not using intersection points, because we're not specifically talking about graphing anymore. Just graphing makes it much easier to see because it's visual. You'll see that it's 2 lines. If they have the same slope, you're going to find out that they either have if they have the same slope, how many answers are you going to find? Either if they have the same exact slope. 2 lines that have the same slope. How many lines?
3.
This line and this line. How many? They're parallel, so no answers. Is it also possible to have the same slope and have the same line? Yes. So if they have the same slope, you're going to have either 0 answers or 2 answers. The idea, or 0 answers or an infinite number of answers. The idea is with systems, you're not always going to find an answer, and sometimes you're going to have a lot more than one answer. In general, that's the basic stuff that we're going to work on here. I know that you probably went over higher number of equations, as at least it says so in the chapter test. But I'm not going to go over that right now because I don't want to know. I don't know exactly how he decided to go over it, so I don't want to mess things up. Now, I'm sure I messed things up enough with what I did. It's really, like I said, I used very simple numbers, or at least very simple answers. And the idea is to make sure that you understand that simple numbers end up turning into simple answers sometimes, but sometimes simple answers come from things that look a lot more complicated than they actually are. So, at this point, are there any questions based on what we actually did? And thank you for not entirely making fun of all of the drawings and the numbers. But is there any other questions that anyone wants to ask at this point? Huh? This is pretty close. All right, then thanks, guys. I appreciate the time. And that was way longer than it needed.